Essentially, when we proved chain rule, we have a ddx, we have a permission to write ddx of f of x as dy by dx, but y is not direct function of x, but it could be function of u. U is not direct function of x, but it could be function of v. V might not be the direct function of x, but it could be of w. May not be the w is a direct function of x. So we are ready to use this, and looks algebraically simple. Du cancel, dv cancel, dw therefore dy by dx. It works like that, but the meaning of that is little different. So this is chain rule. Keep going inside the function and keep differentiating it. So now suppose I want to find out derivative of y is equal to x raised to alpha, where alpha is a real number. What do I do? Y is a function of x and find y dash. How do we go about it? Can you show me your proof? I mean, you may know the answer, but why is that answer? The trick here is we make use of log and exponential functions which are inverses of each other. Log and e. Log and exponential are 1 on 2 functions. Right? Therefore, if we say log to the base e raised to x, operating both direct function and inverse function one after the other makes it equal to x, or e raised to log to the base e of x is also going to be equal to x. Why it is happening? Because they are inverses of each other. Log and exponential are inverse functions of each other. Both are 1 on 2, and therefore if you operate one followed by the other, you end up being where you were, so you end up getting x. So this is good. Therefore we exploit this property of logarithm and exponential to evaluate the derivative of x raised to alpha. So y is equal to x raised to alpha. Therefore what do? We say e raised to log to the base e y, which is actually y, which is equal to this is equal to y, which is equal to e raised to log to the base e x raised to alpha. But then if you look at this power, then it will be e raised to alpha log x to the base e. Okay, right? And then this is our composition function, which is y is a function, let t is equal to alpha log x. Therefore y is equal to e raised to t and t is equal to alpha log x. Therefore chain rule. So if I want to find out dy by dx, what should I do? I should first write y raised to t, dy by dt e raised to t, and dt by dx is equal to alpha upon x. So dy by dt into dt by dx. dy by dt into dt by dx is dy by dx. Is that correct? Which is equal to dy by dx is dy by dt is e raised to t and dt by dx is alpha upon x. However, t is equal to e raised to t is equal to given function. Is that right? E raised to t is x raised to alpha. So x raised to alpha into alpha upon x. That is the answer, and hence you get alpha x raised to alpha minus 1, which is similar to natural numbers, but x here need not be the natural number. So if you are really finding out x raised to half, what is the derivative? Y is equal to root x, which is equal to x raised to 1 upon 2. Then the derivative of that is y dash is half x raised to 1 half minus 1, which is equal to 1 half x raised to minus half, which is 2 root x. Derivative of root x is 1 upon 2 root x. And it will work for any real number alpha. Okay. So what we are trying to establish here is, using chain rule, you can get the derivatives of composite functions very straightforward way. Now find the derivative of y is equal to tan x raised to 3. करा पटकन आणि सांगा, मला दाखवा, बघूया सगळे. बरोबर आहे की नाही माहित नाही मला, बऱ्याच वर्षापूर्वी मी लिहिलंय इथं. बरोबर आहे का? The method is going to be like this. अरे काय चाललंय काय माझं? Log y is equal to x cube log tan x 1 upon y divided by dx is equal to this into this. So x cube into 1 upon tan x into sec square x plus log tan x as it is to 3x square. झालं की बरोबर की? So this is a typical form where you have y is equal to f of x raised to g of x. Okay, so in this case, let us solve it in general once for all. Log y is equal to, now we assume that y is well behaved because it is exponential type of function in RHS. This is going to be positive. That is what we are assuming while taking log. Otherwise, we are not allowed to take a log of a negative quantity. Therefore, if it is f of x raised to g of x, then f of x is supposed to be positive, and therefore y is going to be positive. So that assumption is already there. Log y is equal to g of x log f of x. So 1 upon y dy by dx, that is derivative of log y with respect to x. Again, there is a chain rule. Z is equal to log y. Therefore, dz by dy is equal to 1 upon y. And what is the derivative of y? Y, derivative of y is dy by dx. So dz by dx is equal to dz by dy into dy by dx. So dz by dy by is 1 upon y into dy by dx. So this chain rule is again here also. Now here g of x into 1 upon f of x into f dash of x, derivative of f, plus log f of x into g dash of x. Okay, and now if you take this y to RHS, then dy by dx is equal to f of x raised to g of x, that is common, that is y, inside bracket g of x f dash of x upon f of x plus g dash of x log f of x. That is what is your standard answer when it comes to f of x raised to g of x form. Hope you are understanding. This is easy. Now, next thing that we would like to do is, we have already found out derivatives of basic functions, and amongst the basic functions few are remaining, like y is equal to sine inverse of x. We wish to find out derivative of y is equal to sine inverse of x. I give you a couple of minutes, you do it. Okay, so now before actually solving this y is equal to sine inverse x, let me write down the theorem for in general inverse function, what should be its derivative. Okay, so let me write down the theorem. We will try to prove that and then use that theorem for getting the derivatives of all inverse functions. If inverse functions f and g are defined by y is equal to f of x and x is equal to g of y, and if f dash exists and not equal to 0, then g dash of y exists and g dash of y is equal to 1 upon f dash of x. So what we are trying to say by this is g dash of y is equal to 1 upon f dash of x. G dash of y is dx by dy is equal to 1 upon dy by dx. That is what we are trying to say by this theorem, provided dy by dx is, if dy by dx is not equal to 0. That is what this statement is. because it is getting into the denominator. So this is what, if we prove this once for all, then dealing with inverse functions is going to be relatively easy. Let us look at the geometric interpretation of this first, and we check whether it is correct to say so. Now, inverse function is always reflection in y is equal to x. Suppose we have a given curve like this, y is equal to f of x, something like this. Then if we observe the tangents, say at this point tangent x is equal to this, tangent has got a very high positive slope. Okay. Now corresponding inverse function of this black function is reflection in y is equal to x. Okay. Reflection in y is equal to x, and then this was your y when this was x. When you are going to take inverse, this distance y is going to be your x and this is going to be your y. And then if this is the tangent, then the new tangent will be something like this. Okay. So essentially the angle bisector of these two tangents must be y is equal to x. That is what I am trying to tell you. It's a reflection of a tangent in angle bisector, which is y is equal to x. So what would be the slope of this line? Slope of this line is y upon x, that is tan theta of first tangent. Let me call this as tan theta is equal to y upon x. Okay. And how much is this distance actually? Y dash. It is same as y, but it is on x axis. Therefore, I am keeping it as y dash. Distance is y. And this distance is x dash from here to here. So what is the slope of tangent? What is the slope of tangent? Alpha. It will be x dash upon y dash. Okay, but x dash is equal to x and y dash is equal to y. Therefore, slope of this notation मध्ये काहीतरी गंभीर dash काढून टाकू आपण. Let us take those numerical values. This is y and this is x. Therefore, tan alpha is going to be x upon y, and which is 1 upon y upon x, which is 1 upon tan theta. Tan alpha is the x by dy. This is x and this is y, so dx by dy, and tan theta is 1 upon dy by dx. So okay, geometrically also it makes sense, except geometrically if you have original curve something like this, where your tangent was like this, and it is going to eventually, after your this is not 1 1 on 2, therefore just a moment, I mean if your original curve is something like this, where you have a tangent which is horizontal, then if you reflect that tangent in y is equal to x, the inverse function is going to be something like this reflection, and then at this point, corresponding point, if you try to draw tangent, then it is going to be vertical. Therefore, f dash of x in the original curve should not be equal to 0. That is the only danger point, because vertical tangent we are not accepting. As far as derivative is concerned, it should be exist, it should exist and should have finite slope. Okay, and therefore this is a very good theorem. If we could get through algebraic proof of this theorem, we can finish all the inverse functions very quickly. So I give you few minutes to try and write the proof of this. Basically, we want to prove dy by dx. Dx by dy is equal to 1 upon dy by dx. And if we could prove it, again it is operating like ratio, algebraic ratio. Actually it is not, but it is looking like that, which is good. Therefore, let us prove this theorem. Take your time. Let h and k be corresponding increments in x and y respectively. So y plus k is going to be equal to f of x plus h, and x plus h is going to be equal to g of y plus k. F dash exists implies f is continuous at x, and hence g is continuous at y. As k tends to 0, as h tends to 0, k tends to k tends to 0, and as k tends to 0, h tends to 0. Therefore, consider g dash of y is equal to g dash of y by definition is limit. For y we have given the letter k, k tends to 0, g of y plus k minus g of y upon k. That is what is derivative. But g of y plus k is x plus h, and g of y is x divided by k, which is equal to h upon k. Limit k tends to 0, limit k tends to 0, h upon k. Now as k approaches 0, h tends to 0, we can write g dash of y is equal to limit h tends to 0, 1 upon k h. And this is what I had done there also. So you just take a reciprocal of that here. This is acceptable because you are changing the limit from k tending to 0 to h tending to 0 here. Okay, which is equal to limit h tending to 0, 1 upon k can be written as f of x plus h minus f of x. That is your k divided by h, which is equal to limit h tends to 0, 1 divided by limit f of x plus h minus f of x upon h as h tends to 0. This is equal to 1 upon f dash of x. As f dash of x exists and not equal to 0. So that is what is the proof, and hence job becomes very easy now. If you want to find out derivative of inverse function, you find out derivative of original function and take reciprocal. Therefore, derivative of sine x now. Y is equal to sine x. Sine inverse x. Okay, so here let us write down x belongs to -1 to 1 and y belongs to -π/2 π/2. That is domain range consideration of this function sine inverse x. So we have to have that in mind. So if y is equal to sine inverse x, then sine y is equal to x. Therefore, dx by dy is equal to cos y. Correct? But cos y is root of 1 minus sine y plus or minus radical 1 minus sine square y. Correct? Which is equal to plus or minus radical 1 minus x square. And therefore, dy by dx is equal to 1 upon plus minus radical 1 minus x square. Now, I cannot have two slopes, plus as well as minus. And therefore, I need to be little careful in finding out what is my correct sign. So, if y, cos y, if I want to report, will cos y be always positive? Yes, because y is between -π/2 to π/2, therefore cos y is always going to be positive. Therefore, we need not have to worry about this negative sign. It is not by luck, it is by thinking. So, dy by dx is going to be 1 minus x square. And one more precaution, it is not for all x. If x is not equal to 1 or minus 1, then this is the slope. None of you have written that in your answer, because when you put x is equal to 1 or minus 1 in this, you end up getting dy by dx undefined. And that is why is it happening? Because if our sine curve is sine is like this, white color. If our sine is like this, our sine inverse is like this. And now you know that 45 degree here, slope 1. This is our sine inverse. And if you observe that tangent to sine inverse will exist at every point except these endpoints, it is going to be vertical tangent there. Okay, so even if in the domain codomain of sine inverse you have this one, these are dark points as far as domain considerations are concerned of inverse, but as far as tangent or derivative is concerned, we don't have derivative at the end points 1 and -1, because the lines become perpendicular. So that care needs to be taken while reporting the final answer. And you may be under trouble sometimes if you don't consider this. Might be under trouble. Okay, so now you have five more functions whose derivative is to be found out. But let us go step by step. One is over. Second, y is equal to cos inverse of x. Third will be y is equal to tan inverse of x. Okay, so do this. Tell me what are these two derivatives. Okay, derivative of cos inverse x is minus 1 upon radical 1 minus x square. X not equal to 1 comma minus 1. Derivative of tan inverse x becomes 1 upon 1 plus x square. No restriction. Find derivative of cosec inverse x, sec inverse x, and cot inverse x. Can you tell me what is the domain of x when it is cosec inverse? X can take what values? Bola bola.
minus
minus
infinity
infinity to
to
minus
1,
1 and 1
minus
to
1.
infinity.
So mod x is greater than equal to, and y can take which values?
So minus pi by 2 to pi by 2 minus 0.
So now this is our sine, and therefore this is our cosec, right? So if we invert it, it will become something like this. Okay, so will these points be there? Yes, this point will be there, this point will be there. So this is 1, this is minus 1. So minus 1 to infinity is a domain, minus infinity to minus 1, 1 to plus infinity. And what is codomain? Codomain will be, what will be the y values? You will achieve this, no? So minus pi by 2 to pi by 2 minus 0. Is that correct? Y belongs to Bararli line. Okay. Now, if this is the curve, first thing that we need to observe that there is no place where the tangent is having positive slope. Is that right? What will happen to the endpoints? There will be vertical lines. There will be vertical slopes. So we need to exclude plus 1 minus 1 from our final. But the observation graphically is the slope happens to be always negative. Right. So let us proceed. So that is what is observation. So cosec x is equal, therefore, sorry, cosec y is equal to x. Therefore, dx by dy is equal to dx by dy. You can do it in two different ways. I mean, let us do it in both ways. What is the derivative of cosec y? It is minus cosec y cot y. Is that right? Into, okay, that is dx by dy is this, and therefore dy by dx is equal to 1 upon minus cosec y cot y. We keep it as it is. Second method, cosec y. So x is equal to 1 upon no, 1 upon sine y. Is that another method of doing it? No. You can say y is equal to sine inverse 1 upon x, which is cosec inverse x, and we know the dy by dx is equal to sine inverse आताच काढलं होतं ना तुम्ही 1 upon radical 1 minus 1 upon x square into derivative of 1 upon x square is minus 1 upon x raised to 2. बरोबर चाललंय? अरे हो का नाही? So now here, I mean, let me commit the mistake which you also have committed. Once we simplify this, we get x, actually root x square upon radical x square minus 1 into minus 1 upon x square. That is what you get. And you ended up cancelling this x with one of them and reported your answer. But writing it in this way, it is correct. So far we have not made mistakes. This is correct. But then if you do it like this, x upon radical x square minus 1 times minus 1 upon x square, therefore answer is minus 1 upon x radical x square minus 1, then you are wrong. Because here you are not careful. This should be plus or minus x, okay? And then we go back. Then we go back to graph and check whether we want minus or plus, and we want plus every time. We want plus every time, therefore we make it like this. Or maybe we would have written this directly, radical x square is mod x. Then this business is gone. So mod x upon x square, we can write it as mod x. Still, you need to go back to the graph and find out whether you want slope negative or positive. This is the correct answer. Why? Because if we use without absolute value sign, and if you are evaluating the slope for negative values of x, say minus 2, so dy by dx at minus 2 by your formula which you have shown me would have been minus 1 minus 2 radical 4 minus 1 is 3. So your slope would have been 2 root 3, 1 upon 2 root 3, which is positive. And at minus 2 you will not have slope which is positive, it has to be negative. And therefore this is mod 2 always. Okay. Now can we justify this discussion by looking at this formula? Okay, we will try to do that. Cot of y. We are, where is our y? Y is from here to here. Okay, from here to here. So if y belongs to first quadrant, that is 0 to pi by 2, then cot y is positive, correct? And cosec y is positive. Therefore product is positive. That means we will have negative slope, which is correct. If y belongs to fourth quadrant, then cot y will be negative, because you will have cot y is this quantity which is negative. Cos y does not make any difference. Sin y is different in sign. Then cosec y is, can you tell me the sign of cosec y? Cosec y is 1 upon sin y. Sin y is negative, therefore cosec y is also negative. Hence product is positive. In either case, this product is positive, and which ends up giving you the final answer negative. Now you should shift these guys from y to x by doing some work over there, and you will end up getting this formula. So we can write cosec inverse x d dx of cosec inverse x is equal to minus 1 upon absolute value of x radical x square minus 1. You can remember this formula, which is going to be required. Okay, having done this
सर
yes.
सर ज्या स्टेप मध्ये आपलं येतं ना मायनस कोसेक एक्स कॉट एक्स कॉट वाय सॉरी, त्याच्यात आपण जर ट्रिग्नोमेट्री वापरून केलं की कॉट वाय ला रूट ऑफ कोसेक स्क्वेअर वाय -1 दिलं आणि मग कोसेक वाय विल बी एक्सच ना, कारण कोसेक ऑफ कोसेक इनवर्स एक्स इज एक्स. मग ती मॉडची साईन कुठून येते त्याच्यात?
मॉडची साईन काय?
मॉडची साईन कशी काय येते सर त्याच्यात?
मॉडची साईन आपण कोणत्या क्वाड्रंट मध्ये काम करतोय ते बघूनच येणार. मॉडची साईन, यू वांट दिस डिनॉमिनेटर टू बी पॉझिटिव्ह अँड दिस मायनस साईन विल टेक केअर ऑफ दिस टँजंट. तर तिथे काय किंवा इथे काय, तुम्हाला ते बघितल्याशिवाय तुम्हाला प्लस की मायनस ते ठरवताच येणार नाहीये. यू हॅव टू लुक एट दिस वाय अँड डिसाइड वेदर यू वांट पॉझिटिव्ह साईन ऑर निगेटिव्ह साईन. इथे पण तू रूट घेतोयस ना, एक स्क्वेअर रूट. इथे कोसेक वाय आहे तसाच ठेवलास तरी पण इथे रूट घेतोयस ना कॉट वायला, जेव्हा तू आणतोस एक्स मध्ये तेव्हा.
हो सर.
मग तेव्हा प्लस मायनसचा चॉईस आहे, आणि तो चॉईस एक्झिक्यूट करतानाच हे डिस्कशन आहे. यू वॉन्ट प्रॉडक्ट टू बी पॉझिटिव्ह, यू वॉन्ट प्रॉडक्ट टू बी पॉझिटिव्ह, and then that negative sign will take care of negative slope. You have to be alert in choosing that sign. Okay, if you are careless and by mistake if you choose other sign, then the answer is going to be wrong, because by graph we know cosec will never have positive slope. Okay, and another thing that we need to do is we need to eliminate 1 when x is not equal to -1 and 1. That is what is important here, because again the denominator will become 0. And there are 2 points here in the graph at which the graph is going to be, the tangent is going to be vertical. Okay, so that is what is discussion on inverse trigonometric functions, their derivatives, and cot inverse etc. They are easy, you need to remember them. Sec, for sec inverse x ends up being always positive, therefore the difference is only -1 or +1 or a. Otherwise there is no difference. Okay, so now what next? Now you can do the cases and sketch the graph and deal with it. First of all, instead of discussing differentiability, let us figure out how will this curve look like. So we have done this in 9th standard. If f if x is less than 0, less than or equal to 0, then y is equal to this is minus x plus 1, which is minus 2x plus 1. If x is between 0, less than x, less than equal to or 1, y is equal to, this is x minus x plus 1 is equal to 1. And if x is greater than equal to 1, then y is equal to x plus x minus 1 is 2x minus 1. So the graph of this is going to be to the left of x, it will follow minus 2x plus 1. So this is 1 and slope is minus 2. At y between these two, the answer is 1. So it will go up to 1. And then like this. Okay. So graphically, tangents everywhere exist except at these 2 points, therefore not differentiable. At x is equal to 0 and x is equal to 1. Okay, that is how you can answer. And
0 to 1 च्या मध्ये कसं काय डिफरन्शिएबल आहे?
0 to 1 च्या मध्ये आहे ना, स्ट्रेट लाईन आहे. इथून इथे म्हणतेस ना, आहे ना हॉरिझॉन्टल टँजंट.
हो सर, कळलं.
At every point. So you may note few thumb rules. One, if f of x and g of x are differentiable, in given interval, then, I mean, we have proved this, then f of x plus minus g of x or f of x into or divided by g of x, if they are defined, are differentiable in that interval. If both yes, then their composition or then their algebra is also yes. Now second, if f of x is differentiable but g of x is not, f dash of x exists and finite, but g dash or g is not differentiable. Then f of x plus minus g of x is not differentiable. Okay. Third, if x and g of x both not differentiable in a given interval, then f of x plus or minus g of x may or may not be differentiable, because you can always adjust so that their non-differentiability gets cancelled and it suddenly becomes differentiable function, etc. Okay, and maybe the fourth case, if f of x for if f of x is differentiable and g of x is not, then f of x into g of x again may or may not. So you have to give merit to the function which is given and answer your questions. In general, if both are differentiable, then yes. Otherwise, you have to be careful. So there are plenty of problems which talk about differentiability, etc. So let me give you one more. Numerical f of x is equal to what is the example for this third point? F and G both are F and G both are not differentiable functions, but summation function may or may not be differentiable. It is very simple. Let f of x is equal to mod x, not differentiable at x is equal to 0. G of x is equal to opposite of mod x, not differentiable, at x is equal to 0. But h of x, which is f of x plus g of x, which is 0, differentiable at x is equal to 0. Okay, and f of x, same, mod x. G of x, same, mod x. So h of x is 2 times mod x, not differentiable at x is equal to 0. So you get a function differentiable, you get a function which is not differentiable, given first both functions not differentiable. Okay, so unless and until you know what these functions are, you really cannot predict about these people. However, both of them are differentiable, then their summation, difference, product and ratio, all four of them will be differentiable. That is what is there, point number 1. Okay, so let me give you another example, easy. Find the values of a.
So what is the answer for continuity for this one?
0, not continuous.
Yes, sir.
Not continuous at x is equal to 0. not differentiable at 0, 1 and 2. That is the answer. Okay, next problem is find the value values of A and B if f of x is equal to A plus sine inverse x plus B if x is greater than equal to 1, x if x is less than 1. If this function is differentiable at x is equal to 1. Okay, f dash of x for this case, okay, इथे नको लिहायला, is equal. If x is greater than equal to 1, is equal to 1 if x is less than 1. And now it is differentiable at x is equal to 1. Therefore, both the derivative values should be same. तरच ती tangent असणार ना. अरे f of x is differentiable at x is equal to 1 दिलाय. त्यामुळे तू लेफ्ट साइडने आलास 1 आहे. सपोज असं फंक्शन आहे. This is 1. So this is from left. Okay. So if you approach 1 from left hand side, you get slope 1. बरोबर? And if you approach from right hand side, what slope you should get at x is equal to 1? Again 1. So this should be this derivative of this, that is slope of the tangent, when you reach x is equal to 1 from right, should be same as that of this. Limit should exist, left hand limit, right hand limit, derivative साठी. त्यामुळे दोन्हीचे स्लोप इक्वेट केले आणि मग b ची व्हॅल्यू शोधून काढली. b आला -1. बरोबर आहे. आणि मग डिफरन्शिएबल आहे म्हणजे कंटिन्युअस पण आहे. त्यामुळे दोन्ही व्हॅल्यू ऍट x इज इक्वल टू 1 सेम पाहिजेत. म्हणून a ची व्हॅल्यू आली इक्वल टू 1. समजलं का? परम ओके. थोडे कॉम्प्लिकेटेड ए बी असतील असे देतो. द्या. सेम स्टोरी. अशी शेकडो गणित तुमच्या सेंगेज मध्ये आहेत. ती पटापटा सॉल्व करायची. नंतर आता नव्हे, आता तुम्ही 1/3 चा करताय अभ्यास. लेट f of x is equal to a root x plus 1 between 0 less than x less than 3 and bx plus 2 if 3 less than equal to x less than 5. If f of x is differentiable at x is equal to 3, find a comma b. Correct. Next problem is, okay, value of a is 8/5 and value of b is 2/5 in earlier problem. Next problem is find derivative of y is equal to x raised to 2/3 into x to 4/3 plus x raised to 1/3 plus x raised to minus 5/3. 2x plus 1 minus 1 upon x square. Now let me see whether this is difficult. Find the derivative of y is equal to sin x plus 1 raised to x at 3 pi by x is equal to. Easy है तो difficult है क्या? Okay, so maybe log y 1 upon y dy by dx is equal to x into derivative of this. Okay, x into log of x. This is the function x log sin x plus 1. So x into derivative of second, which is sin x plus 1. Derivative of sin is cos x. Correct? So this is first part plus second is log of sin x plus 1 into 1, which makes it sin x plus 1 times log of sin x plus 1 plus x cos x upon sin x plus 1. So now divide by right, then this is equal to multiplied by sin x plus 1 bracket raised to x. Is that right? So we can write it further as sin x raised to, hey, cancel होना दोगे and वहाँ sin x plus 1 raised to x log sin x plus 1 plus sin x plus 1 raised to x minus 1 into x cos x. तर याच्यात तुम्ही x च्या जागी 3 पाय बाय 2 टाकलं की उत्तर 0 येते का?
हो सर.
Yes. Okay.